So we're going to learn about methods, and essentially each object has its own methods. And methods are essentially ways of condensing code into smaller areas, and that you can use them to repeat. Methods are usually methods of other objects, like a scanner object, can be called by writing the name of the scanner, and then applying a dot, which tells a program I want to call a method, and then the name of the method after that. This case, and essentially, in this case, the next int method essentially tells the program that I want you to go inside the scanner class. I want you to find the next int method and do whatever that says. And in this case, what next int does is essentially it goes to the input area down here and essentially grabs the next user input, and then it returns that that input as an output and so essentially replaces the entire thing with that output, which is why you can then tell a program to put it inside a bucket. All methods are essentially mini programs. They have inputs, operations, and output. In this case, nextInt does not need any inputs, since its program, its function is always going to be the same, grabbing the next number from a user input. So no matter what input you might want to give it, it wouldn't change its function. Its operation is simply grabbing a number, and its output would be taking that number and outputting it. So when you type this, it would output the next user input number. So this would essentially replace itself with a number like 9. And then this 9 would then get assigned itself to this int. So essentially, this is the same thing as writing int a equals a number. Except the next int tells us that it's going to be a the next int tells the program how to get that number. Another way to call methods is by writing out the method specifically. And this only works if that method is written out in this class. So let me write an example method real quick. This is an example of what a method might look like. Like I said before, methods are essentially mini programs that allow you to shorten your code. And essentially, if you need to use if you find yourself using a specific piece of code multiple times, you can use a method to try and reduce the amount of words cluttering your screen. And in this case, this method its output will be an integer. Its name is add, and it needs 2 inputs, a number A and a number B, and it will return these 2 numbers added together. This is essentially an example method, and it's kind of similar to how nextInt works. Except the way nextInt works is that here it has no parameters or input. It doesn't need any parameters or inputs, and its return is simply the terminal down here. It returns whatever you type. You can type your own methods by simply writing them out like that. Public simply just means anyone can access the one. Public just means anyone can access this method, and this right here is really the more important stuff. It's essentially, and its form is similar to writing other like for loops and stuff. So this is essentially what a method is. A method is just simply writing a mini program to accomplish other tasks that you might need in your main program. And like any other program, it has an input, it has an operation, and it has an output. So to reiterate, this specific method is called add, and you need to give it 2 numbers, and then it will return these 2 numbers added together. If you wanted to use this method, first of all, you would need 2 inputs. So like, for example, this, and you can't repeat names. So A, B. And if you were to write, for example, int c is equal to add A, B, right, and get that state. You could then this C would be equal to 2. So to call a local method, or a method that's not contained in an object or in an object like scanner, one that you wrote out yourself, you simply have to call the name, add the necessary inputs, and then just simply use its output to do something. In this case, I use its output to store a number. So yeah. And if you want, remember, if you want to use a method that's not, that you didn't write out, but is located somewhere else, like in a scanner object, you would have to write out the name of the object, a dot to tell the program you want to write a method, and then you would have to write out the method name. Just so, okay, and let's talk about how this relates to the rock, paper, scissors program. In the program, first of all, you're going to need two pieces at a minimum, 2 pieces of data. The player one's choice, or essentially if they picked rock, paper, scissors, and player two's choice. And you don't technically need this, but it's always a good idea to add lots of sys and out different lines. So like that way, like you'll know where your program is. So like, for example, like simply just typing stuff like this out. So now you would have 2 pieces of data. One is whatever the player 1 chose in his rock, paper, scissors game, and second would be whatever player 2 chose in the rock, paper, scissors game. They could type, like, say, rock, paper, scissors. And for right now, we're going to assume that they typed correctly. And so that way we don't have to deal with any exceptions, any error cases, like if they typed, if they typed turtle or something. If they do type something like that, then that would be considered essentially, depending on what it is, it might be considered like a logic error. But for right now, we're going to assume they typed it correctly. So we have 2 choices, and now we need to compare them. And to do that, to remember, if you do want to do comparisons, if you want the program to do something based on, if you want the program to vary its output based on the input, you need an if function. Because remember, the if function has a piece of code that will only run if the inside question is true. So if it's not true, then it won't run. So for example, you can say if P1 choice equals rock, right? So in this case, this is essentially saying if whatever the user typed, if his word is equal to rock, then do something in here. And you might notice instead of using P1 choice equal rock, equals the string rock, I used dot equals. And this is because when you're comparing, the computer finds it difficult to compare numbers the same way it compares words. For words and most objects, it wants to use this method here. But for ints, you can just use double equal equal. But since P1 choice is a word and rock is a word, the program finds it difficult to use this to do this comparison wise. So if you want to compare words, you want to use dot equals. And if you want to compare numbers, you want to use a double equal sign. You can't use a single equal sign. Because remember, if you use a single equal sign, that means you're replacing a value. You're not comparing a value. If you use int, we already used the equal sign in writing stuff like int a equals 5. You can't reuse it because the equal sign can only have one purpose, and the program won't. If we gave it 2 different functions, the program won't know when to use which one. So that's why comparisons using numbers use a double equal sign. Otherwise, you need to call a dot equals method. And remember, and so in this case, dot equals method also has an input output operation. And basically, essentially, its input essentially is the thing you're comparing it to. So you have object 1 and object 2. Its operation is doing comparison inside this method, and then it returns true or false. So if this is true, right, we'll then need to compare player 1's choice with player 2's choice. So we can then write, for example, if player 2 choice dot equals, I didn't spell it right, rock. And again, here we're simply comparing players 2 choice and whether or not it's equal to this string, this word right here. And if both of these are true, then this code inside here will run. And so if both player 1 and player 2 both chose rock, then there's only one possible outcome, which is tie. And we can then repeat this piece of code for all player 2 choices and repeat this for all player 1's choices. And then that way we'd have a work round procedure that works for one round. For example, how would you rewrite this so that it checks scissors instead? And also how would the system output line change? How would you rewrite this piece of code to compare rock and scissors? To compare player 1's choices rock and player 2 choices scissors? How would you think you would do that? Sort of. It's essentially, it's very close to the same thing. You would simply rewrite the same thing and rewrite it with scissors. Then, but you would also have to change this to say something along the lines of player 1 wins. So let's go through this one more time. If functions take a true or false question, and then depending on whether if it's true, it will run the code after it. If it's false, it'll skip straight to the end and not execute anything in it. So if we want to, and they're usually used for comparisons. You compare two things, and depending on whether whether or not the comparison like works, like for example, you can compare two numbers, and if the first number is bigger than the second, then you might tell the program run this code. But if the other number is bigger, then do something else instead. Did you raise your hand, Dylan?
Yeah. So for this, like if player 1 choice equals rock, would you have to write that thing a whole 9 times, or is there another way?
Are you saying like do we have to rewrite this 3 more times for scissors and paper? Is that what you're saying?
Yes, and then also for player 2 and.
Well, in this case, yeah, because what we're comparing right here is unique words, and it's really difficult to like make a way to essentially go through a list of words. One thing you could do, I guess, is create a list, an array of choices. And then put the choices inside. So there you go. So one thing I guess you could do is this, and instead of going through p1.choice equals rock, you would do a for loop instead. It would iterate through each one of these.
Okay.
Then if it equals this, if it equals this, this, or this, and then it will go through p2s, if this, and this. And then you can instead compare the two numbers.
Okay.
If both numbers are the same, that means, okay, so like, and then when you look at the specific number is going to be the position of their choice in the list. So if their choice was rock, then you would give them a number 0. If it was paper, be 1. If it was scissors, it'd be 2. And you would compare the two numbers. And in this case, you would only need 3. If the numbers are the same, like 0, 0, 1, 1, or 2, 2, then it's a tie. If if player 1's number is 1 bigger, so like 1 to 0 or 2 to 1, then player 1 wins. If player 1's number is 1 smaller, like 0, 1 or 1, 2, then they lose. And then you would also have to make sure, and for scissors, right? When compare 0, 2, yeah, sorry, it's not one bigger one, but essentially if player 1's number is bigger, and player's 2 numbers not 0, then they win. And if player 1 is smaller, but player 2 is not 2, then they win. So you could also do it like that.
Okay.
Yeah, the reason, but this is way less confusing than having to like convert to numbers and then compare and then make sure you do like the math stuff, right? This is a bit less confusing, but it does take a little bit more typing. Essentially, it's sort of like in English class where when you write an essay, you could try to write it really short and like really short, but it's kind of hard to get it detailed. Because if you write it, if you try to write fast, it's hard to put all the detail. But if you write it out long like this, it's a bit safer. It's a lot easier to read through this because this is easy to read through, much easier to read through.
Okay.
Yeah. Also, you can also use control copy and paste. There is one other method, and also there's one other method, and it introduces a new function called switch. Switch isn't used much because it's basically just if. Switch is just essentially a multiple if statement, but a lot of people just prefer writing out multiple if statements because people are lazy. But switch statement can make this faster too. And switch works like this. You write the word switch, and you write P1 choice here. And then you would write case. That's not what I meant to write. Okay, so switch is very similar to if. It's essentially some person some time ago decided he didn't like to write out all of these if statements. And so he wanted to know that, and so he created his own function called the switch that would essentially allow you to write out multiple if statements easier. And so in this case, it works like this. When you write switch and then P1 choice, you tell the program, okay, take this in, this is your, tell us the program, this in this function has an input P1 choice, and it's going to compare it to each case. And if it's ever true, it will run the code inside the case. So in this case, if P1 chase is equal to rock, it will run case rock. If it's equal to paper, it will run case paper. And if it's case scissors is true, it will run whatever's in here. And you might notice there's a break after all of these. Technically, you don't need a break, but what happens when you get rid of the break is that the program keeps going. So if, for example, P1 choice is equal to rock, I'll run rock, and then we'll also run paper because there's no break statement here. Essentially, there's no stop sign. The word break acts like a stop sign for any sort of loop or a function. Essentially, if you write a for function and you put a break in it, it will tell the for function to break the repetition early as soon as it reaches it. So essentially, break works like a stop sign saying, you see that loop you're doing or whatever, stop it now. So you can think of break as a break or a stop sign, like a car brake.
Okay.
So if by putting breaks here, essentially tell the program, these are all individual cases where if one is true, you don't run the others. If you got rid of the breaks, then you got rid of the breaks, then what's happening here is if the first one is run, it'll run everything after that because there's nothing to stop it. It'll run all the code after that, so on and so forth. Essentially, it's basically like if comparing to if statements, if you didn't add the break, it would be like saying if choice equals rock, and the second statement would be if it equals rock or it equals paper.
Okay.
So you would have to repeat that multiple times, or you can try using the new switch statement, or you can try using that. There are, again, it's pretty open. Programming is pretty open-ended unless you're trying to work on a very specific question. So there are quite a few ways to work on anything. In fact, there's even this can actually be rewritten in a different way. For example, let's look at this one. If we wanted to check ties, for example, one way we could rewrite this if statement would be like this. Right, if P1 choice is equal to the word rock and P2 choice and this piece of code is saying if this is true and this is true, then run this code. Essentially, we have conjunction operators, which sounds like a big word, but it's pretty simple. We have and or, and these are the 2-point ones. And basically just means the two true or false questions. If both are true, then it will do something. But if one is false, it will immediately stop because it's and. They both have to be true, or means at least one of them has to be true. If both are false, then nothing. Then it'll return a false. But if at least one is true, return true. Or essentially, if we have an equation, right? Like A less than B. If we have a true or false equation, right? And this equation can only return two values, true or false. This equation is sort of like another operator, like that's like greater than or less than, and that you take two values, you compare them, and then it will return a true or false. In this case, you could, for example, create a variable c to store the true or false number here, right? No, the true or false, answer. And you could have a second variable to store another true or false answer. And then you can use a conjunction operator, like double and or double or, and you will compare these two, and then this one will output another true or false. And then you'll do something based on that. And this one's the same thing, except again, in this case, only one needs to be true instead of both. So in this case, if both of these are true, then this code will run. If I change this to or, then as long as one of these is true, whatever is in here would run. And you can also keep combining these. You could continue writing more ands like over here. Because remember, you can think of it as like a math equation where you can write multiple pluses, like multiple like operations, like 3 plus 5 plus 6, 7 plus. And the way the program looks at it is essentially condenses the first three, and then condenses the next two, and then it condenses next. In this case, if you add an extra and, it will first look at these two, figure out if this will return a true or false. Since it's an or, if one of these is true, it'll return a true. And then we'll look at the next conjunction operator, and then the next variable or number or true false symbol to be compared, and then we'll compare the two true or false values and return based on whatever it is. So this is another way of actually rewriting it. You could just write a bunch of, for this rock, paper, scissors program especially, what you would have to do is you can only use ands because or doesn't tell you anything. You would need to know both values. So rock, rock, or rock, paper, rock, scissors, and then you can output something based on that. Of course, this program only works for a single round of rock, paper, scissors. If we wanted to play multiple rounds, how do you think we would do that?
Maybe by putting it in a loop, but only like restarting it when the program has finished running.
So I see a lot of interesting answers here. So one way you could do it is by recopying this code, everything, and copy pasting it. And while that does work, that only works a limited number of times, as it won't only work as many times you want to copy it. And it's possible you might copy paste it too many times. Like the players only want to play twice, but you copy paste this code like 3 times for 3 rounds. So a better way would be to vary it based on user input, like what you just said. So for example, one we could do is simply write here, how many rounds, and then it's simply get the user to input a number. So if they type 3 rounds, then we would then use this number to try to figure it out. So someone also mentioned in chat a while loop. While loops are also another thing I was going to talk about later. Essentially, you know how for loops repeat, right? You give them some variable to track, and they will repeat some piece of code as long as a condition is fulfilled. And as soon as that condition is no longer fulfilled, then it will stop it right there. Usually for loops, you give them a number, and then you tell the program as long as this number is less than this other number, and you constantly increase the numbers you keep track of until it's over, and then it'll stop there. A while loop is essentially the same thing, but a bit stronger. So a while loop simply writes the same way. In here, you only need one thing rather than 3. You only need a condition. So for example, in this case, our condition can be like this. And what this is saying is run this code while P1 choice equals rock. And if you don't put anything in here, it will run forever, because assuming P1 choice is rock initially, because since there's nothing inside here, P1 choice doesn't change, so it's always equal to rock. you need to do something like, for example, you need to edit P1 choice somewhere in here to equal some other string. You can also, most commonly, we use this with numbers. So if we were to use the number of rounds above, we could say, for example, we could have heck. What did I do? Oh, hold on. My screen is blocking. So what we could do is we could create as an I, like we usually do in for loops, and we can simply write while I is less than rounds. And then inside here, we simply do I is equal to I plus 1. And well, this basically means repeat this, and eventually it'll stop because I will at some point be larger or equal to rounds. And then we could simply take all of this code. You take all of this code, and not that one. Here we go. And put it in here. Oh heck, I need it. And then we need to obviously get rid of this because it's our argument. So, that's how essentially a while loop is a for loop, but instead of putting the changing condition inside here, you put the change outside. You could also use a for loop instead, which would simply be the same thing, but you put everything in here instead of in the 3 different positions. So a for loop would be essentially the same thing, except instead of putting the entire stuff outside, you put it all in here. And this is essentially saying, we create a number I, we set it to 0, and while this number is less than rounds, we run numbers in here. And every time this inside code finishes, we increase this number by 1. And when I is equal to or greater than rounds, it will end. And then the program will end here. Yeah. So that would be essentially how you would do a rock, paper, scissors game. And yeah. Don't forget to use dot equals. Remember, the way the program compares numbers and words and objects are different. You're comparing an object or a word, it has to be with a dot equals method. The reason is because words and objects are considered like stuff rather than numbers. And so each stuff has their own equal method that really should be used. Yeah. So yeah. Let's go now. If you remember yesterday, one other thing we talked about was arrays. Specifically, arrays are simply like lists. You have to tell the array how much you're holding, how much it holds, and then you can put stuff in this array as long as it doesn't exceed a limit. And in order to put stuff in the array, you have to first of all tell the program exactly what position it's going to be at, and then you can fill that position with something. So in this case, we create a list. Has a size of 10, and it holds numbers. And we tell the program then that in this list, we want at position 1 to have the number 4. Remember, Java and basically every programming language always counts from 0. So when you type a 1 here, this isn't actually the first position. This is the second position. When you put a type 0, then the program will put the 4 in the very first position of the list. Yeah. And also, you can't write 10 here because since it starts from 0, the only possible positions would be 0 to 9, because that would be 10 numbers, and thus that would fill up the entire space. There's no 10 because otherwise it would need 11. If you wanted to use the 10, this would have to have a size of 11, and the positions would go from 0 to 10. Now, we can use lists to code another game, like tic-tac-toe. The reason is in tic-tac-toe, we need some way of storing positions. Or in other words, and remember, lists can store the data with positions. So that helps us a lot. So so let's see how we might be able to do a tic-tac-toe game. So first of all, is everyone, by the way, is everyone comfortable with rock, paper, scissors? Do you think you guys could finish the rest of it by yourselves? What do you guys think? You guys think you could finish the rock, paper, scissors game by yourselves? Chat, you could.
I think so.
Cool. Yeah, I'll post this video later, so you can always review it if you need to. But yeah, so let's take a look at another game we could create. Another pretty simple game. Tic-tac-toe. Tic-tac-toe. So we can keep this beginning code for rounds, and then we can then put in the for. All right, and we can put our actual game in here. So let's think about how we might write tic-tac-toe. The most important part of tic-tac-toe would be a board, right? And in this case, what we could do, so in this case, we could either create, what we could do is create three lists like this. And each list would hold a different row. Or we could, drum roll please, create a single double list. Gasp. Yes, I know this is extremely surprising and awesome. All right, so the way a double list works is essentially instead of so you see how here when we write it out, we're saying this list, this double bracket has a type of integer. So in other words, this list is only capable of holding number things. When you try to put a word in this list, it won't work because it's designed for numbers. And here, it works a bit differently. In this case, this list is capable of holding a list. And this list is capable of holding numbers. Essentially, it's a list of lists. If you want a visual representation, would probably look something like this. So this is what a normal single list would look like. But right, so like this is a list with five numbers. Let's make them different. 5 numbers. I would add positions go from 0 to 4, and right now you can see it's holding something, right? A double list would, instead of having a number at each position, it would have a list at each position. So it would instead look like this. And these inside lists have a type of integer. Because remember, look, the typing goes, it's a list that holds lists, that holds numbers. So these inside lists can hold numbers. So then inside these lists, we might have like 0, 1, 2, 3. Something like that. And the reason it's related to tic-tac-toe is because if we just change the look of this a little bit, like say like this, and make this contain one less number. Fine. Okay. As you can see, this might start to look familiar. In other words, this is how we're going to store our tic-tac-toe board. It's a 3x3, and it's a 3x3 board. And you could and every time the user types in the position, you could change the inside of this list to something else. All until someone wins. Da, 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 da. Essentially, you can think of a double list in a kind of graph format, where you have different rows and different columns. And in order to find, if you want a single number, you would need both the row and the column. Now, if you want to actually like do stuff with the board, you know how to access inside. For normal lists, you would simply call a list name, put down the brackets and type in the position. If I want the number at position 12, I would write, if I want the item at position 13, if I want the item at position 12, I write 12. If I want the position at 0, I would put 0 here, and that will return whatever number is in the list and is at position 0. For a double list, you simply do it twice. This case, this is saying, you're telling the program, I want you to access the list board. I want you to find the first or the 0th list, the list at the list at position 0. I want the number of that list at position 0. So in other words, this would get the first list stored in the double list and find out the number. So in our example, this will essentially be the number in the top left corner. So if I wrote 0, 0, it would say, go to the first list, find the first element, the 0th element, and it would return, and you could grab it out or something. Or you could write, for example, this is equal to 3, and that would change this value to 3. Or if you wanted the value, you could write and say is equal to, and that would return 3, which is what that position right now. If you wanted the items in the second list, you would have to write a 1 here because it starts from 0 to 1 to 2. If you want the last list, you would write 2. And if you want like the last element here, write 2. And you go 2, 2. You can just think of it as like a coordinate graph, and these are your coordinates. Except instead of going left to right, bottom to top, you go top to bottom, left to right. So you'd start from 3 and go, okay, so this is 0, 0. This is 1, 0, 2, 0, 2, 1, 2, 2. This 0 has a coordinate of 2, 2. This one has a coordinate of 0, 0. This one has a coordinate of 0, 2, et cetera, et cetera. So that's how we would store the tic-tac-toe. Firstly, let's see if we can find some way. So let's test it out. So first off, we would need to know where they want to put it. In this case, you're right. You can simply use scanner, grab the necessary numbers. And remember, when you choose a row column, if you want to test it out as like a player, when you choose a row column, make sure you remember that it starts from 0 and goes to 2. You could change it to start from 1 to 3, but you have to like keep that in mind for your entire program. So now your row column. And since this is, and we're going to assume for right now, P1 is X, P2 is O. We're going to stick with this. So if you wanted to change if you wanted to put down player 1's position, how would you do it? We have the row and the column. So how would you write out, for example, if P1 is X, right? We can represent X as 1, which like player 1. Since this is a number list, every single number in there is a 0. And if we can represent X's as 1s. So we can change the number in the board to a 1. So for example, we could say the board at this row, or essentially, and when we say, in this case, row is representing the numbered list. The first list is the first row, the second list is the second row, the third list would be the third row. And you have to make sure, of course, that it's 0, 1, 2. And then the first list at column, or in other words, the position in that row is equal to 1, or in this case, X. You could also change this to a string or characters and put like X, like with the actual character X here instead. But I find it's a bit more convenient with just numbers. Since we only have 3 values to worry about, 0, 1, 2, and they're fairly easy to remember. 0 is empty, because like the value itself. Player 1 is X, which is 1. Player 2 is 2, which is 2. So now we have this. How would you write out? So I want you to type in the chat or say it out loud. How would you find player 2? How would you get player 2's position? How would you get player 2 position? How would you access it, and how would you change the board? Oh, that's good. So someone asked if we need to save the board before making another change to it. And the board is similar. It's essentially like another bucket, like another variable. You don't once you do this, then this place is changed. You don't really need to. It's not like a file where you have to like save it and then like change it. The thing you do have to watch out for though, while writing it, is make sure you don't like change it too early. Like for example, if this position already has a thing here, right? There already has a symbol there other than 0, then this is not allowed, and you'd have to tell the person to choose a new row and column. So specifically, you would have to write, you could check it by using if. And that would be enough. If this area is empty, then we can change it to something else. And to do player 2, you could then just simply copy this over. And then like that. We can use row and call again because remember the equal sign essentially replaces the number inside this bucket. So by calling the method next int again, and when it returns a number, this number replaces the old number row. The old number row is now gone. It has the new number, and same thing with column. So now that there's a new number row and column and it's player's choice, you can then put it inside the board. Check if it's first off the space is empty, and then you can sign it. There should be 2. So that's how you get player 2's choice. That's all I want to go. That's pretty simple. We'll grab the input. But now we have to do what's the much harder part, which is checking for wins. You probably want to do this between each player's move. And so, and also one thing to note is that since the check wins is probably going to be exactly the same for both, except we simply change who's checking, we can actually make it a method. So let's show off a bit. Essentially, what's going on in this method is that this method called check win takes its input is the player, and it also needs the board. So you give it the board and a player, and then it will return true or false, depending on whether the player wins or doesn't win. So for example, you could say, so Boolean essentially stores a true or false value, and we could say this. Essentially, this one would just simply say, take a variable name A. It's a bucket that stores true or false values. And then if the number at position 0, 0 is equal to the player, then assign a true value to A, otherwise assign a false. And then we can simply return A, and that will return true or false value. In order to act, but we want to, of course, make a check for all of the 3x3 wins. Now, this is a bit complicated. So now if we want to check horizontal wins, we probably would need a for loop because we're going to repeat through each row, and each row is going to be essentially exactly the same. We're going to look at each individual element inside that row until either they match or they don't. Since there are 3 rows, we can simply, the beginning of this for function is fairly easy. We repeat this 3 times. Then we want the row is saying, I want you to go to the board that you get from the input, access the row number I, which remember is going to be 0, then 1, then 2. So it's going to check through every single row because this for function is going to loop through all the numbers. After you get that row, take that row, take that row, which is a list of integers, and put it inside this bucket. So this bucket row, which holds a number list, now holding the number list inside this board. We can then iterate, we can then repeat through this one. Actually, or you could just do this every time, just do this. Actually, this is probably a bit simpler. Yeah. So, and you could just do this. All right. So here, oh wait, shoot, I put this in the wrong spot. Okay. So here what's saying is repeat this. This for loop is going to repeat everything inside 3 times. And this for loop is going to repeat everything inside here 3 times. So in other words, it's going to repeat a total of 9 times. This is going to repeat this one 3 times. And since this one does three times as well, we're going to run this inside code 9 times. This inside code basically goes at row I in position J, we compare it to the current player number. And remember, since this for loop is inside this for loop, that means this for loop changes its values before this one does. So essentially, it's going to look through here, say, oh, it's a for loop, we'll continue on. It's a for loop, continue on. And when it goes here, and when it finishes everything here, it's going to reach the end of this for loop. And then it's going to increment, it's going to increase J by 1 and repeat this 3 times. Then it's going to finish this for loop, move on to the end of the first for loop, and then I will go up by 1. So essentially, usually the numbers will go I is equal to 0, J is equal to 0. Then it will still be A with 0, but J is equal to 1, because this is inside this for loop. So this happens first. So then I is equal to 0, and then J is equal to 2. And now I is equal to 1, J is equal to 0. The reason is when J is equal to 2, when we add 1 to it, it becomes 3. So then it stops, goes to the end. And since the end is the first for loop, it goes back to the beginning, but this time with I increased by 1. But J is now reset back to 0 because now we're calling a new version of this for loop. The first one was finished because it got to 3. But now we recreate the for loop, so it starts from 0 again. Then this will continue on. And after the inside for loop finishes again, I can now move on to 2. And eventually it would stop once I equals 2 and J equals 2, since at that time both of them would finish. And then now we would have to run this through. So essentially, now we want to make sure that every single value, so this time we're checking rows. So we want to make sure all the values of J, because remember J changes first. So we're going to open list at position I and look through position 0, position 1, and position 2 of that list. So, and if all these positions, all of them equal player, that means he has to have a 3 in a row. Remember? We're gonna since I changes like last, I is going to stay constant while J is going to keep switching. So essentially, it's going to be picking one list at a time and then repeating through each of the individual elements inside. So if I is 0, J is 0, it would go to this element first. And since I stays 0, but J increases to 1, it stays in this list and moves on to 1, then to 2. And then once I increases to 1, it will move on to the next row or the next list. And then so I is equal to 1, but J is equal to 0. So look at this element. I is equal to 1, but J is equal to 1. So list 1, position 1. I is equal to 1, J is equal to 2. So list 1, position 2. And then I'll start again with 2. By this way, we'll check each individual row. And then we'll have to have some way of actually checking whether or not they win. You could, for example, in this method, you'll probably want to use an if loop. And where you can either, for example, check whether or not it doesn't equal, because if there's a single time where it doesn't equal, then this entire row is kaput. But if there's a single time it does equal, but if every single time this never gets triggered, then you're good. So you're gonna have to do some way, you're gonna have to check that some way. If you want to check columns, you could do the same thing, but you would instead just flip these around. Okay, it's time, but real quick, what do you think happens in this for loop, these two for loops, after we've swapped the position of I and j? Remember, here I and j have stayed the same, but now this time they're changing differently. What do you think happens here? What's the difference? In this case, what would happen is j changes slower than I. If I essentially in this example here, all the i's will become c. So you can see here, remember, in this case, j changes slower than I. J would become 0, and I would repeat all the way from 0 to 2, all from 0 to 3, and then j would change. So in this case, it would be j is equal to 0. Then you would start this for loop, and I will go to 0 to 1 to 2. Then j would be equal to 1 because this inside loop would finally finish and would reach the end of the first for loop where we finally do the j++ that occurs at the end. Remember, for a for loop, the add always occurs at the end after everything inside the loop is finished. So this first for loop doesn't increase its number until after everything inside it is finished. So this gets to finish first. So I would go from 0 to 2 before j could get to 1. And once j gets to 1, I get to go from 0 to 2 again. Now let's look at the word position. In this case, because I is changing first, rather than the list being constant and the position of the list changing, the list is changing, but the position inside the list will stay the same. So in this example here, let's see. J0, I0, so row 0, column 0 will be here. And this time, I changed to 1. And since I is telling us what list we're going to move on to this list instead. Since j is still 0 and j marks the position inside the list, we'd be looking at this element instead. And then when we move on to here, the position is still the same. Since j is still 0, it's still going to look at the first element inside each list. Because I is 2, would now be moving on to the third list, or the list at position 2, which would be here. Then j would finally change to move on to 1, while I would reset back to the first list. So by switching these two around, you can then check all the verticals. Diagonal is much, if you want to check diagonals, the only really real way to do that would be by manually writing out the code instead, since there's only 2 diagonals and they don't relate to each other. But yeah, try to work on this a bit by yourself at home and see how far you can get. We'll rediscuss this in our next class, and then we'll move on to actually like showing out graphically, because after all, you can't play tic-tac-toe without actually seeing the board. So in the next class, we'll focus on actually writing out the board to other people so they can actually see and use it. But that's the end of our class. If you have any questions, you can say bye. I'll upload the video onto the class and also write out this assignment onto the classroom as well. Other than that, good day. Other than that, that's the end of my class. Yeah.
So we're going to talk more about how to make a tic-tac-toe game.
Yeah.
Right?
I'll look at your I'll look at your progress, and then I'll adjust it a bit, but we will essentially go through it a little
Okay.
bit more.
All right. Bye, Daniel.
Bye.